topics for today is acids, bases, and salts. We are looking at acids, bases, and salts. So we first start with acids. We look at acid. Now, what do we mean by an acid? We define an acid. Let's say an acid is a substance which produces hydrogen ion or hydrozonium ion. As the only positive ion when dissolved in water. Prior to this time, you have been taught electrophilic compounds. And one of the things you know about electrophilic compounds is that when you dissolve them in water, they have aggregate of ions. They dissociate into the aggregate of aggregate ions. For example, your sodium chloride, if you dissolve it in water, you have your Na plus and Cl minus. Potassium chloride, you have your K plus and Cl minus. You now discover that the positive ions that you have in electrophilic compounds varies. It could be sodium ion, potassium ion, calcium ion, magnesium ion. But in the case of acid, anytime or whenever you dissolve them in water, what you have as a positive ion is hydrogen ion or hydrozonium ion. And that's why we define acid as a substance which produces hydrogen ion or hydrozonium ion as the only positive ion when dissolved in water. Now let's look at the classes of acid that we have, or the types. The classes of acids. We can divide acid into organic acids and inorganic acids. The first one is organic acids. Now, what are organic acids? Organic acids are acids that are obtained from natural products. You obtain them from plants and animals. So these are obtained from natural products. Natural products. That is plants and animals. So organic acids are obtained from natural products, they are obtained from plants, they are obtained from animals. Example now, let's look at examples. Now, ethanoic acid is one of the examples. Ethanoic acid. You derive your ethanoic acid from vinegar. Another one is lactic acid. Lactic acid is obtained from milk. You obtain now from milk. Another one is fatty acids. Fatty acids are obtained from fats and oils. That is fatty acid. Then we have the citric acid. The citric acid is obtained from lime or lemon. Then we have amino acid obtained from proteins. And then we have ascorbic acid, or what we refer to as vitamin C, obtained from oranges. So all these listed acids, they are organic acids because we obtain them from natural products. You get them from other plants or animals. Two, we have the inorganic acids. The inorganic acids are obtained from mineral products or you say from inorganic matters. So these are obtained from mineral products or inorganic matter. For example now, you have hydrochloric acid, that is HCl. We have tetraoxosulfate 6 acid, that is your H2SO4. We have triazole-nitrate acid, that is HNO3. So these are inorganic acids. Now let's look at strong acids and weak acids. When you hear the word strong acid, what do you understand by that? And when you hear the word weak acid, strong acids and weak acids. Now what are strong acids? Strong acids are those that ionize completely in water to produce the hydrogen ion and the anions. Strong acids are those acids that ionize completely in water to give an anion and hydrogen ion. So these are strong acids. For example now, talk about HCl. HCl will ionize in water to give hydrogen ion and the chloride ion. HNO3, that's a triazole-nitrate acid, will ionize in water to produce hydrogen ion and the triazole-nitrate ion. Another one is H2SO4, will ionize in water to give you hydrogen ion and tetrasulfate ion. These are strong acids because they ionize completely in water. Now, what about weak acids? So, look at one word here. This one ionize completely in water. But for weak acid, they ionize partially. They ionize. So, weak acids are only partially ionized in water. Only partially ionized in water because they have low concentration. They have low concentration of hydrogen ion. Low concentration of hydrogen ion. For example now, when you talk about your H2CO3, that's why we have only 4 acid. H2CO3, this one we ionize partially to give you 2H plus CO3 2 minus. Then you have H3PO4. This one ionize partially water to give us this plus PO4 3 minus. Then when you have your ethanoic acid also. This ionize partially water to give to give us H plus CH3COO minus. Now, have a look at strong acid and weak acid. Now, let's also look at concentrated acid and dilute acid. Concentrated acids and dilute acid. When you have large amount of water in small amounts of acid. We say that acid is that the resulting solution is dilute acid when the water is very large. But when you have little or no water in a large amount of acid, then we refer to that acid as a concentrated acid. We refer to it as concentrated acid. So you can take note: concentrated and dilute acid. So, like I said, if a large amount of water, if a large amount of water is added to large amount, let's say to a small amount of water, to a small amount of acid, rather, small amount of acid, okay, the resulting solution is a dilute acid. Take note of that word. You have a large amount of water added to small amount of acid. Now let me put it this way: large amount of water plus small amount of acid. That gives us dilute acid. But when you have small amount of water added to large amount of acid, that gives us concentrated acid. So that is just different between the two. Now let's look at basicity of an acid. Basicity of an acid. At the beginning of the class, we said acid contains hydrogen ion as the only positive ion when you dissolve them in water. So which means that the major components or the major ion that we have in acid is hydrogen ion or hydrogen ion. So when we are referring to basicity, our attention is drawn towards this hydrogen ion. So what is basicity? Basicity of an acid is defined as the number of replaceable hydrogen ion in an acid. That's what we refer to as basicity of an acid. Is the number is defined as the number of replaceable hydrogen ion in one molecule of an acid. For example, now, if I have HCl now, the basicity of this one, I'm having one hydrogen ion that can be replaced. The basicity of this one will be mono-basic. That is one hydrogen ion can be replaced in this. So I can replace this hydrogen ion with sodium to become sodium chloride. I can replace with potassium to become potassium chloride. If I have H2SO4 now, the basicity is 2. 2 hydrogen ion can be replaced there. That makes it to be dibasic. So I can replace this one with potassium. If I replace with potassium now, it becomes K2SO4. If I replace with sodium, it becomes Na2SO4. So I'm having 2 hydrogen ion here. I've replaced with 2 potassium ion. So if I have H3PO4, the basis of this one will be 3, and that is tri-basic. If I have CH3COOH, the basis of this one is 1, and that is monobasic. It is only this hydrogen ion that can be replaced. So if you look at ethylic acid, there you have 3 hydrogens, here you have 1 there. This one cannot be replaced. It's only this hydrogen ion that can be replaced, and that's why it is a monobasic acid. So that's the basicity of that one. Now let's now look at the properties of acid. We look at the physical properties of acid, and also we look at the chemical properties of acid. Now, the first thing, let's look at the physical properties. What are the physical properties of acid? Physical properties of acid. Number 1, correct. Dilute acids have surface. Dilute acids have surface. The taste is sour. The number 2, acid turns blue litmus red. If you dip a blue litmus paper inside an acid solution, it turns red. The number 3, acids are corrosive. Concentrated acids are corrosive. So these are the physical properties of acids. Now let's look at the chemical properties. The chemical properties of acid. Number 1, let's look at the reaction with base. Reaction with base. That's the first one. Now, when acid reacts with base, the end product will be salt and water only. So acids react with base to form salt and water only. What we are saying here is when you have acid plus base, you are going to get salt plus water. For example, now, acid is ACl, base is NaOH. So at the end of the day, what you have here is this sodium chloride will join with sodium, join with chlorine or chloride ion here. That will give us sodium chloride plus H2. You have the hydrogen here, you have the hydroxide ion. That gives you water. You can also have, let's say you have H2SO4 plus KOH. This gives us this, with this will give us K2SO4 plus H2O. That's the first chemical properties of acid. They react with base, bases to form salt and water only. Another one, acid reacts with metals to liberate hydrogen gas. So number 2 is reaction with metals. Reaction with metals. So acids react with metals to liberate hydrogen gas. So though it is not all metals, it reacts with metals that are highly electropositive, the most reactive metals to liberate hydrogen gas. For example, now, if you have, let's say, have Zn plus HCl, you are going to get Zn plus H2. This is displacing the hydrogen ion from this compound. You can also have, let's say, you have Na plus H2SO4. So you are going to get Na2SO4 plus H2. So hydrogen gas is liberated at the end of the reaction. Another chemical properties of acid. So reaction with carbonate 4. Reaction with triazocarbonate 4. So acid reacts with triazocarbonate 4 to liberate carbon 4 oxide. React with triazocarbonate 4 to liberate carbon 4 oxide. For example, we have NH2CO3 now. This is sodium triazocarbonate 4. Acid react with it to give us NaCl plus H2O plus CO2. So this is the triazocarbonate 4 gas that is being liberated in this reaction. We can also have, let's say we have H2SO for now, reacting with K2CO3. This will give us K2SO4 plus H2O plus CO2. And this is carbon dioxide that is being liberated. Now let's talk about the preparation. How do we prepare acid? Preparation of acids. There are so many ways or methods that we can prepare acid in the laboratory. The first one is combination of the constituent elements. The combination of constituent elements. For example now, look at that your hydrogen chloride that we have here. The two elements that are present in that acid are hydrogen gas and the what? Chlorine gas. So I can combine the two elements together. And when I combine them together, I'll get my hydrochloric acid. So that's combination of constituent elements. You can get prepare your acid through that method. Another method of preparing acid is dissolving an acid anhydride in water. Dissolving an acid anhydride in water. Take note of the word acid anhydride. Actually, acid anhydride are oxides of non-metals that when you dissolve them in water, they are going to give you acid. For example now, my SO2 is an oxide of non-metal, which is sulfur. If I dissolve this one in water now, I'm going to get my H2SO3. Another one is SO3, what about my SO3? Dissolve this one in water, I'm going to get H2SO4. What about CO2? If you dissolve CO2 in water, you are going to get H2CO3. So in the example, they ask you to give them 3 examples of acid anhydride. You can give them SO2 as an example. You can give them SO3 as an example. You can give them CO2 as example. They are oxides, like I said, they are oxides of non-metals that when you dissolve them in water, they tend to give you acid. Now, another method of preparing acid in the laboratory is by using a strong acid to displace a weak acid. Using a strong acid to displace a weak acid. That's another example. For example now, we have potassium chloride and H2SO4. I'm going to have what here. Look at this. This gives us K2SO4 plus 2ACl hydrochloric acid. So these are the methods of preparing acid in laboratory. I told you number 1. Combination of constituent elements. Number 2, dissolving an acid anhydride in water. And And the third one, using a strong acid to displace a weak acid. Now, finally, what are the uses of acid? What are the uses of acid? Now, acid can be used in the production of fertilizers. One, used in the production of fertilizers. Then you can also use acid in the production of drugs. Used in the production of drugs. Then you can also use it in the production of detergents. In the production of detergents. So these are the aspects or the things they expect you to know as far as acid is concerned. One, you need to know the definition of an acid. As I stated it at the beginning, a substance that produces hydrogen ion or hydronium ion as the only positive ion when dissolved in water. Then you need to know the classes of acid. I've told you we have two classes of acid. We have the organic acids and we have the inorganic acid. And I've listed the examples of the organic and the other one, where you can obtain them from. Organic acid, we told you that they are obtained from natural products, plants and animals. Your lactic acid, your ascorbic acid, fatty acid, amino acid. Then we have inorganic acid, your H2SO4, HCl, your inorganic acid. Then we have looked at concentrated acid and the dilute acid. When you have a large amount of water in small amount of acid, that is a dilute acid. But when you have a small amount of water and a large amount of acid, that's concentrated acid. Then we have looked at strong acid and weak acid. Strong acid ionized completely in water. Weak acid ionized partially in water. So you know your classes of acid, then you know the preparation of acids. I consider the three preparation of acid. Then uses of acids. Then we talk about the basicity of an acid. Number of replaceable hydrogen ion in one molecule of an acid, that's basicity. Then you should know your properties of acid, the physical properties and chemical properties. So in our next class, we'll be going to basis and salts.